Okay, so this is going to be my Chapter 7, Week 7 exam video on patterns. I have all my 10 questions here, nothing on the back, but yeah, let's get started. So, the first question is, how many species have been named approximately? So there have been 1.5 million species named. Question 2, do we know all the species on Earth? Provide a piece of evidence. So we do not know all the species on Earth. We don't have an exact number. Our best approximate guess is 8.7 million, which kind of goes to show if we have 1.5 million named, how many there are to still name. And there are lots of reasons as to why we do not have a number on all the species on Earth, but one piece of evidence as to why would be basically, I guess one example would be not a lot of species, but some species can look very, very similar. They can look completely the same from the outside, but maybe something internal is what differentiates their species. And it can be, since it can be so hard to differentiate these species, there can just be species that go unnamed. And yeah, that's one reason as to why. Question 3, explain how biodiversity patterns can be used to predict the number of species in the world. So biodiversity patterns, such as like where a species is, or how many of a species lives in a certain location, we can use kind of these methods and patterns to predict the number of species in the world. But a lot of the times we run into a lot of problems and a lot of limitations. For example, one example of this is the body size frequency distribution, and that is that there is a number of, basically scientists took the number of species and then plotted it against body size, and what they found was that there's a lot of small-bodied species compared to large-bodied species, but there's a gap in the small-bodied species on the graph where it shows that a lot of these species are unnamed and there is problems, and it just doesn't really account or explain for all the species in the world. It's definitely a big scientific question to tackle and ask. Question 4, describe a limitation of some of the methods used to quantify how many species there are in the world. So basically the body size frequency distribution would be an example of this limitation. Another example of this limitation is species area range. I believe I'm saying that right. Species area distribution. Basically, it was a study done by Grassel and one other person, I'm not too sure. But basically, the study they did was that they looked at a section of the Atlantic Ocean, and they collected a bunch of data on the species that were there. And then they took their data numbers from this one section of the Atlantic Ocean. They extrapolated it to like deep ocean floor, and their conservative estimate was 10 million species in the ocean. But this, obviously, they kind of have a mistake in their reasoning or their methods, and that big mistake is that they didn't really account for the biogeographical range or regions, because obviously the ocean is going to have different species and different types of species and numbers of species from different depths. And yeah, that was definitely a mistake they made, and a limitation. But yeah, there's lots of limitations and problems because it's such a big question to ask. Question 5, in the opinion of experts, how many species are there in the world? What is the implication in this large range? So based on experts, there are anywhere from 3 million to 100 million species. And the second part of the question, what is the implication in this large range? Because there is such a large range, it leaves great uncertainty for being able to contextualize different species. And it can just cause a lot of vulnerability for certain species because there's such a big range. We're just like unsure what's right and what's what, and it's just hard to contextualize and study, which leaves a lot of species very vulnerable. Question 6, what is the best approximation to how many species there are on Earth? Why is this the best approximation? So, our best approximation is that there's 8.7 million species on Earth, and this is our best approximation because basically we took the taxonomy of a species and then looked at all the different taxonomic levels, and by accounting all the different numbers of the taxonomic levels compared to the number of species, we are then able to have our best guess number. But it's definitely just looking at each level of the taxonomy. What question was it? Question 7. What will it take to describe the remaining undescribed species on Earth? It will take 1,600 years. It will take $364 billion, and it will take 303,000 taxonomists to find the other millions of species on Earth that are unnamed. So it's definitely a huge feat. Lots of time, lots of money, lots of taxonomists. Question 8, what is a synonym? A synonym is basically the same species that can have like different names, often because of different languages that have different names for the same species. Question 9, how are global patterns in species richness created? So basically, global patterns in species richness are created by, there's two different ways. One way is taking the geographic ranges of a species and then overlapping it with specific like pixel plots that this certain species need to be accounted for, and basically by overlapping the range on top of the certain pixels and then seeing where the certain species fall in the pixel. Second is data, by just collecting census data, sampling data, and then looking at the specific data and then looking at the specific points where the data is collected and then comparing it to the species richness. Question 10, what are some of the limitations in data used to outline global diversity patterns? So there's kind of two different limitations that I'll talk about. The first limitation is range. A species with a larger range kind of underestimates species with smaller ranges, specifically like endemic species. And basically it can just cause kind of a certain level of vulnerability for the species with smaller ranges, because the species with large ranges just kind of overpower, kind of like take up the space of the smaller species. They overlook smaller species range. And then the second would be just like the lack of, or the limitation in census data. An example of this is looking at our oceans. Only 1.8% of the world's oceans have 80% or higher of the fish fauna named and accounted for, and that's only 1.8 of the world's ocean. So that's the whole rest of the oceans that are 80% or lower of fish fauna named. So that's just so much of our ocean that is yet to have that 80% threshold of species names because of the limitations, lack of data that we have on the oceans and in the world in general. So that was my 10 questions. I'll see you in the next video.